All right, so we're going to talk about increase, inputs, and what we call selection. This lecture probably will be in two parts, so we'll do about half of it, and then we'll continue the remainder next week. So, yeah, so if we talk of inputs and selection, what do we mean here? So, let's look at the assignment or the exercise we ended up with last week. So we had this. It said write a Java program that declares variables to represent principal, time, rates, and interests of a simple interest loan. So we're saying that somebody is taking a loan over some time and want to calculate how much interest the person has to pay. And then to calculate that, we use an equation. So interest is this. And we want to print it out like this. So we want to print out your loan of, so if it's say 1,000 cedis, at the rate of this, and so on and so on. So how do we go about this? I was saying that if somebody has done it, but I don't think we'll have the time for people to go through this. So what I'll do is I'll just show the code, and then we'll build on that as we go along. So if you look at it, the thing says variables represent principal, time, rate, and interest. So here, what are we going to do? If we are going to declare the variable, we are going to be looking at using something that can accept decimal points because we are dealing with money. And so money comes in pesos. And so you can't use integer throughout. Or if you use integer and you put 10 cedis, 50 pesos, the program is only going to see it as 10 cedis. It's not going to add the 50 pesos. And so when it comes to money or other things that involves decimals, you need to use double. And so the assignment said declare variables to represent principal, time, rate, and interest. So here, first of all, we declare our variable, and it also says, so if I go back, it also says any name of your choice. So you can decide to give them any names that you want. So okay, you can decide to give them any names you want, but I've decided to just stick to the principal, the time, and the rate because they are not Java keywords. So none of those is a Java keyword. So you can use principal as a variable name. You can use time, you can use rates, and then you can use interest. So that's what we have. So here we've assigned a value to principal. So we're saying that this is how much the person is going to borrow. We put integer time, and now let's see where the commenting becomes necessary because here we are saying that you can't just do time and leave it as this without any, because nobody can tell what does the 15 mean. If you say time is 15, is it 15 months or 15 days? No, so you need to add a comment so that we'll know that, or anybody reading will know that they're dealing with years. And then we have what we call the rate, which is the percentage. So it can be 0.25 or 25%. Okay. So now this is what we're going to do. So we've also declared a variable called interest. And now we've done the calculation. So principal times time times rate divided by 100. Okay. So here now we are printing it out. So we are saying system.out.print your loan of, and then we concatenate the principal. And then we continue. See this at a rate of this, and then we continue per annum because that's what the assignment says. So it says print it out like that. Your loan of this and all that. And so you need to be using the print method and then find a way of doing the concatenation so that you ensure that you get the sentence clearly written out as it is. So let me go back to our IDE. Did I close this? Okay. Okay, yeah, so I'm interested. So let me open this. Is it there? Okay, all right, so let me take out this so that it doesn't confuse us for now. And Okay, another one. We'll take this out. Oh no, let me take it out. We'll use it. We didn't use it now. So we have this. So let me just, So this is what we have. So we have principal, and we assign the value to it. So we said you can assign any value. You can 5,000 cedis. At 50 pesos. Okay. At over 15 years at this rate, and then that's our equation. So we've now assigned values to all the variables. So the principal has a value, the time has a value, rate has a value, and interest has a value. So what the computer has done now is to create space in memory, label them with these names, and then put these values inside the corresponding names. And now when you are doing the calculation, so when you do this, you are asking it to go into the principal variable or space, look at the value that is inside there, take that, multiply by what is in time, multiply by what is in rate, and then you divide by 100. And then this is what we are printing out. So we're saying that your loan off, and then we bring the principal. So, and then we continue. So concatenation, cedis at a rate of, and then we bring the rates, and then per annum. And so, well, I just broke it out into two so that we have. So if I run this, so run as application, okay. So it's now printed out your loan off. So realize that it has concatenated the 500.5 cedis at a rate of 0.25% per annum. Or if you look at this, I said rates, and I concatenated the percent here per annum. So this is treated as a text. So it's just joined to the 0.25%, and then over. So this line ends here, and okay, so that ends, or that's, and then we continue here. So you can leave it as one line anyway, it doesn't matter. But over a period of 15 years, because that's the time, as an interest of this. So we didn't assign this to the interest, but the system did the calculation, and then it has provided the interest. So by merely assigning values, we can now determine. So if another person borrows 10,000, okay, I can calculate that person's interest as well. So if I run this, then for the 10,000, the interest becomes 375 cedis. If you borrowed less, maybe if you borrowed 50 cedis, so 50. So here, you borrow 50 cedis, then of course your interest is going to be much lower because so interest is 1 cedi, 8 expenses. So okay, so this is just a way of, and the trick, especially when you're writing this for the first time, is how to get this thing to print out as clearly as it is here, because you realize that if you say your loan off and you don't include a space before you close the quotes, you see, if you don't do this and then you run, what you are going to get is that it will just join. You see that this is your loan off, and it just joins the 50.5 cedis. Because now, if you put the space here, that doesn't make sense because Java doesn't know what the space is. If you put it in the quotes, then it will treat it as a string. But if you just spaces in the code, Java doesn't recognize it. So you can put as much space here as you want. If you run, you are going to get the same thing. So here, so long as you didn't put a space here, all the space doesn't mean anything. So it still has it in there like that. So you need to be able to know how to put the spacing and realize that after the principal, then before you can bring the cedis, there was another space before. Because again, if you leave that out, then you are going to get another situation where you get, something like this, 5.5, 50.5, no space, and then cities. And so we always have to be careful when we're writing out this thing so that you're sure that you are getting the spacing right. Most of the time, you always run it before you come to realize that you've omitted some spaces and other things. Anyway, so that's why we say that when you do it, or when you look at it on paper or on the screen, it looks easy. But when you're asked to actually write it and run it, then you realize that no, there are so many deficiencies that you still have, because unless you run it, you wouldn't see some of these minor issues. Okay, so once we've done this, now immediately we can see the shortcoming of a program like this, because what we are trying to do here is we are trying to calculate interest for people who have taken a loan. So if this is a bank and you have 1,000 people coming to take loan, what it means is that each person, you are going to come here and change this. So somebody comes and say, I'm taking a loan of 100 cedis, or so you put 100 here, and then you run, and then you calculate the person's interest. So you say, okay, your interest is 3 cedis, 75 pesos. Another person comes, I'm taking 20,000. So you put 20,000 there, or this 200,000, whichever. You run, and then you can say, this is your interest you have to pay. Now already we see that doesn't make sense. I mean, you can't be opening the code all the time to type in something, and you expect the computers don't work like that. That's not making good use of the resources. Yeah, so I don't know why it's yeah. So what it simply means here is that this, of course, we know computers don't work like that. The easiest way to do this is to ask the user to type in how much you want to borrow. So if the user types in, then you can print this out rather than you typing it in individually. So it will be the same code that is running, but each user will type in the amount they want to borrow, and then the system will calculate their interest for them, not you, the person sitting down, and then when the person comes to say, I'm borrowing this, then you type it in, and then you run, and then you tell the person, this is your interest. So this already tells us that, the program here, or what we've written, is totally inadequate. And so something has to be added. And so that's where the input now comes in. So we now need to have something that will tell the user, type in the amount you want to borrow. And then when it types it in, we'll take that value and then assign it to the principal. So what it means is that when we're declaring the principal, well, we can have a value inside, or we can put 0, or we can leave it blank, whichever. And then when the user enters what the amount they want to borrow, then we can take that value and assign it to the principal. And so that's where the whole idea of input comes in. So we're now going to look at what we call input, and that is taking input from the user or accepting input from the keyboard. Now, when we say input, as far as computers are concerned, there are so many ways of inputting data or information into computers. The keyboard is one, the mouse is another. You have microphones that you can use to capture voice. There are cameras to capture videos. And these days, even with virtual reality and other things, you can do hand gestures or movements, and all those can be sources of input. So you can have a virtual reality game where you are maybe boxing somebody, and as you are throwing your punches, the system is responding because it's taking input from the user. And so sometimes just movement can be a kind of input, and so on. So there are several ways of inputting data into a system or a computer. For now, we're just only going to look at the keyboard. So when you type, we're not going to get to the point where you use the mouse, because the mouse will require a window, and then a whole lot of other things that listen to the clicks of the mouse and so on. But for now, we're going to look at how we can take input from the keyboard. So we're saying that in most cases, yeah, programs that only produce output, of course, they have a lot of shortcomings. You need interactivity. So the user should do something, and then you can take that and then maybe show or print out something to the user. And of course, that's how computers are expected to work. Without interactivity, then the computers are pretty much useless, because there's no difference between that and the manual paper things that we do. So in this case, to accept keyboard input, we need another class and method that is embedded in Java already. We used the system.out when we are printing something onto the screen. And so now to take something from the keyboard or the screen into the program, we need another method or another way of doing it. And so we can still use the same system.out, because out is an object that works with methods that output, for now, let's say text onto the screen. So out cannot be the same that will be able to take in information or data. So we need another one that we call system.in. And so when we are doing the output, we use the print method or the print line method to display our strings and variables. But now when we want to ask the user to type in something, we need another approach. And so this is where the whole idea of another class comes in, called the scanner class. So the scanner class is in Java. And then when you want to get the program to take input from a user, you need to bring in that class, or you need to have that class. And then there is a way to create an object within the class. And then that object is what we'll use, what we call the input method, to be able to capture data into the system. And so it's just like, so here, because you want to get, and that's why we say Java is object-oriented. Everything you do in Java has to be worked on with what we call objects. So it's the objects that are using the methods that have been described within to do all the actions or the functions that we see when the program is running. So, and an object is normally created from the class. So we have a class, and then we can create objects from that class. And so if I can demonstrate this, normally when we, where's my annotation? So when we create a class, so if I type something like this, if I say public, it doesn't matter, class, and I say, let me just say Copies House. This is a way of just, okay. So what have I done here? I have created a class called Copies House. And now within Copies House, we can create objects. So the objects here, or not only objects, but objects and methods. And so within that class, these objects can use the methods that we created in there, to perform whatever functions or duties that we want to be performed. So here, if I want to create an object in Copies class, we use the keyword new. So anytime you see the keyword new in Java, what it means is that we are going to create an object from the class. And to create the object means now that I have Copies class, I can decide that, okay, I want to create an object called Kojo or Ben. So let's say Copies House is a house of human beings, okay? So now the human beings inside Copies House are the objects. Now what the human beings can do are the methods. But because I'm creating everything from scratch, I have to describe all those things within the class. In Java, there are some classes that have been created already that have certain things that you can use. But if I'm writing a program, of course, Java cannot take care of all those ones for everybody. So I have to create my own classes and objects and describe what I want those things to do. So now in Kofi's house, I want to have maybe Ben, and so Ben should be able to wash a car, because those are the activities or the functions that can be performed. I want to create another object, Amma, and Amma should be able to cook, just like I mentioned the last time. And so I have to describe all those things within the class. So without that, of course, if you create an object in what it means that if I just said, if I had Kofi's house and I had human beings inside, and I didn't describe any methods or other things, what it means is that all those human beings are just there. They can't do anything because I have not described what they should be able to do. And so to be able to create, and we don't necessarily have to just create the objects. You always create an object because you want that object to be able to do something. And so to create an object in Kofi's house, the first thing I'll have to do is to bring the house. So because you are writing a Java program that has so many classes, and so you need to specify which class. So I will now put Ben. So the Ben here is the object I am creating. So a new Kofi's house. So if you see this, what it means is that I'm now creating an object called Ben in Kofi's house. So this is our object. I can do another one, in which case I'll have Kofi's house. So here, Kofi's house. And then, like I said, Amma. Now here mostly we use lowercase, so new house. So what have we done? We have created two objects. Okay, house. Okay. Created two objects. So one is Kofi, the other is Amma. So this is the keyword for creating new objects in Kofi's house. So what it means now is that if I go in once the program is running, if I go into Kofi's house, I can see two objects. And those objects are Ben and then Amma. But then what can they do? I have not said anything about what they should be able to do. So within the whole class, this is the whole Kofi's class, because once we create this, like we said, you always have an opening. So there's an opening, and then I can easily, and then a closing. So everything that let me, I shouldn't, well, I've cleaned it already. This thing is, where it's undo, okay. I only wanted to clean this one. Yes, this one, So I wanted to indicate that when you create Kofi's house, we always have the opening. And somewhere at the end, we have the closing. So within this, we can describe a whole lot of things, the methods, and then we can have variables and other things. So if here within Kofi's house, I say integer age 10, if I do this, what it means is that I'm saying that anytime you create an object in Kofi's class, it will have this attribute, or it will have to inherit this. That is, that person's age is going to be 10. So now in this case, Ben will be 10, Amma will also be 10, because that's what I would describe within the class. And that's why we say the class, we say is a blueprint for creating objects. So when we talk of blueprint, we look at it like the plan of a house. If you want to build a house, there's always a plan. So that plan is on paper. So it's drawn, it says, okay, this is where the door is, this is where the kitchen is, and all that. This is 3 bedrooms and so on. So that's the plan you are going to follow to build the house. So you can look at the plan as our class that we have defined. And now we're using that to build the house. So the houses that we built are the objects. So we're creating objects out of that class. And so we can build several houses using the same plan. So all the houses will look identical. They will look, I mean, it's just like the apartments that people build. They are exactly the same because we're using one plan. But being the same doesn't necessarily mean that they all are doing the same thing. You know, it all depends on what you have decided. You can decide to paint one blue and paint another one white. But that should all be defined inside the class. If you said paint should be white, then all the houses that you are going to build will have to be white. You know, and so on. So the class is the blueprint. So when you are creating a class in Java, you need to include all the other things that you want the objects to be able to do. So if in the Kofi's class, I have another, I create an object, I mean a method called cook. We'll come to creating methods later on. You know, so then it means any object I create out of Kofi's house will have the age being 10, and then the only activity they can carry out or function they can carry out is to cook, because that's what has been defined within the class. They can't do any other thing. If you want them to do any other thing, then you have to include it in there. And so the house, so it tells you that you can create as many objects as you want out of the class that you have defined. And so here, where is this? This my annotation doesn't seem to. Yeah, you can create as once you have a class, you can create as many objects. It's just like you can have a plan. No, you can build 10 houses with the same plan, 20 houses. In fact, the plan cannot be cannot finish because it's just a blueprint that is on paper. You can't say, oh, when you create 50 objects or you build 50 houses, then the plan is finished. You can't build it. It doesn't make sense. So what it means is that you can create as many objects as you want, and they can do all the things that you have described in it. So if in building the houses, for example, I find out that, or maybe the place I'm putting the houses, maybe there's too much water, and so maybe I need to raise the thing a bit. I have to go back to the plan and say that, okay, now the house should be, 2 meters high and not just 1 meter, or maybe 10 meters high, and so on. And so when you do that, it means you are changing everything, every other object that you have created will now bear those attributes. In other words, if I write a program that now comes to say that, okay, or as I run the program, I get to a point where I say age. Age is now, just like we're doing our variables 12. Now, what it means is that, at some point I was creating objects, or the objects had age 10, but it gets to a point, I say age is 12. So now all the other objects that are within the class, the age is going to be 12. And so when we say object-oriented, that is what Java allows us to do. We create classes, and Java has inbuilt classes. There are thousands of them. In fact, when we started learning Java, these were not that many. So, but now there are thousands and thousands of classes that Java has created. And then there are methods within those classes and even objects that have been created. And so you, the programmer, all you need to do is that just go to the class and say system, for example, .out, .print, and then, of course, everything is done for you because everything has already been described or coded within the class in Java. But like I said, Java cannot create everything for you. You have to, if you are creating an application for your Keep Fit Club or your church or whatever, what happens is that there's no way Java could have estimated all the type of classes you would need. So you now have to come and create your own classes, create your methods out of those classes, your objects and all that, and then you can get them to perform whatever functions you want to perform. So to take input from a user, you need to go to the scanner class that Java has already created, and then you define an object. So this is an optional word. It's up to you. I'll use input here, but you can use anything. You can use your name. You can use just like how we saw Ben or whatever. And then we'll say new scanner, and then There's this system.in. So this also tells you that the system is a class. We've already come across a system.out in the printing or to print out. So what we're saying is that when you create that object in the scanner class, it should be able to take input. That it should be able to, so system.in is more like another class that has defined how input should be taken from the keyboard. You know, when you hit the keyboard and you see something on the screen or it appears on the screen, I mean, to you, the user, is very simple or it's straightforward. But to the computer, a whole lot of things happen because hitting the keyboard, remember, computers work with zeros and ones. So what goes on within that converts, what you have typed into the text on the screen that you see. It's a whole lot of things because converting the zeros and ones to graphics or text on the screen, it takes a lot. So, but you need things within to be able to do that. And so when we create this input now is an object that is capable of taking input from the user. I'll use input just to make it clear, but you can use another thing. So what we're saying is that we have created an object, so we call this a scanner object, and then we've assigned the reference input. So input, we can decide to call this, or we can look at it like it's a variable, because you can see that you are assigning something to it. Once you see the equal sign, but we wouldn't call this a primitive data type that we looked at, like the integer and all those things. This we call an object. Now we want this object to be able to take input. It's just like if I go back to Kofi's class, I want to create an object, Amma, that should be able to cook. Okay, so I can say Kofi's house, Amma, new Amma. Then I need to put into brackets, what the person should be able to do. So in this case, it's cooking, but even cooking what? So it's just not a matter of saying to cook, but the person should be able to cook either rice or whatever. So all those things have to be specified. And so if I leave this out, what it means is that I can create an object called input, but as an input in the class, I have not determined what it should be capable of doing. And so like Kofi's house, I can have so many human beings in there, but I've not trained any of them to be able to do something, to drive, for example. So if I want to say, okay, I'm going to create an object that should be able to drive, or I want a human being in Kofi's house that should be able to drive, then when I'm in the process of creating it, then I need to indicate that, the person should be able to use this method or should be able to drive and so on. So you can create objects out of classes. Some of them might be able to use some methods, all depending on how you did the creation in the first place. So when we're creating our input or our object to take input from the user, we need to indicate that it should be able to access the system.in, because that is where things have been defined. That works out how you can take input from the user. And so once you do this, what you have done is that you have, let me end this, and then I can move on to the next. Sometimes the screen just freezes. Okay. Now, so once you create your object, the next thing to do is to make it take the input. And so how do you do that? And so there's a method also within Java that you can invoke that the object will use to take the input. And so that method is already described or defined in Java, and everything has been coded. And so now that I've got my input as my object, the next thing I want to do is that I want to I want to get a double integer. No, not double integer, a number, which is a double. I could have used integer or whatever here. This is the name of a variable, value. So value can be anything. It's up to you. It can be time, it can be date, it can be principal, whatever. And now this is the syntax I need to be able to get the input from the user. So I've created the object, which is input, and then dot the method. And so like we saw, system.out.print. So it's always the object dot the method. And that's where it can now do the actions that we want. So ama.cook and so on. So here it says input dot next double. So what it means is that I'm going to get input from a user, but the value should be double. I could have used integer, and then I'll have to say input. So this input is coming from, this is the object that I've used. If I used another name here, if I do a Ben here, then I'm going to say Ben dot next double. Or I can say dot next integer, dot next float, and so on. And these are already defined. So the keyword next followed by any of the primitive data types tells you that it's something that's already defined in Java, and then you can use it to pick input from the user. So these two lines are very crucial if you want to be able to interact with the user, because you ask the user to type in something. When the person types and presses enter, what happens is that this is now invoked, and so you create the object. Now you use the object to take the input from the user. It's like asking somebody to go and buy maybe a newspaper or something. So you need a human being, and then you need the person to be able to take money and buy the. Now, of course, computers don't. These days, there's artificial intelligence where computers pretty much try to do things on their own, based on millions and millions of data that they have analyzed. So we call that artificial intelligence, but it's still, of course, being something that is emerging. But if you look at it technically, computers are dumb. As somebody would say, they don't know anything. They are just machines. It is you, the human being, who will tell it what to do. It's only that they can do things faster, because they can run things in millions of times per second. So if you say multiply 10 by this, by this, by this, computer will do it in a split second, whereas a human being might be taking a long time to, at the end of the day, the computer knows nothing. It is you, or the human being, who has to tell it what to do. And so you need to create the objects and then tell the object that, okay, there's already this class in there. Inside this class, there's this method. So go and pick that method. That method will show you how to do this and that and that, and then you can bring it back. So here, what we are doing is that we've just asked the input object to take the next double method. So you realize that anytime you see the open and close brackets, like I said, it tells you that this is a method. And so take this, and then what that does is that it will read input from the keyboard and then assign what has been typed to value. So it's just like I would have written double value and assign 10, or double value, and or like we did double principal and assign 400 cedis. Now we're saying that let the user type it in. But when the user types in, somebody has to go and pick it up and bring it and assign to the value. Java doesn't automatically just get the, so you can't just say double value and then ask, maybe ask the user to type in, and then once it's typed in, then it's assigned. No, it doesn't work that way. You need an object that will use a method to be able to do that. So at this point, you are now able to read values or data from the keyboard and assign to variables. So these are two critical lines you need when you want to take input from a user. Without this, there's no way Java can be able to take input from a user. So if we now go back to our program that we wrote, printing out our interests and other things. Now what we want to do is that we want the user to type in the principal that they want to borrow. and we'll take that and then do the calculation rather than we, the person programming, opening the code and typing it in, hard coding. We call that hard coding. So before you can, so it's the same program, like as you can see. So we have the double, we have the principal, we have the time, we have the rates. But what has happened now? The principal, we have declared it. We have not assigned a value, unlike the previous one where we said principal and then we assigned 400 or 500 or those things. And now we are printing something. So we said system.out.print, please enter amount to borrow. But you can say maybe type in how much you want to borrow or whatever. And then when that is done, so the user, once the user hits enter, then we do this. Scanner input this. So we create the input object from the scanner class, and then we use that to pick whatever the user has typed and assign to the principal. So principal, and that's why, because principal is double, we are saying .next double. If principal were integer, we will say .next int. If it were float, we will say .next float, and so on. So that's the corresponding way of going about it. But now you can see, yeah, anybody has a question? Okay, if you have a question, you can just raise your hand so that we can. All right, so, but for what you can see that's a bit different is that at the top, before the public class, there is this import, java.util.scanner. And what does that mean? What is happening is that when you create your Java program, and that's why in the IDE we have the Java project. Once you say you've created a Java project, Java imports some very essential classes into your program. So they are in the background running, even though you are not writing them, they are there. Just one is this system.out. And where is it coming from? We have just decided to write system.out.print, and then it actually displays what we want it to display. But that tells you that there's something that's already written that is in there, or programmed that is in there. And system is a class, then object, then method. Now, so it means when you created your Java application or your Java project, the system class was already part of it. And so you can just use it. So it's like in your school. You are in GCTU, Tesano. You want to go to the library is there, so you can go in. You want to go to the cafeteria, you can go in, because by default, those are already in the, let me disable, yeah, okay. Because those are already within your class, if I'll put it that way. But now if you want to use something that is outside, your class, you need to actually import it. So that the syntax we use in Java is import. So when you use import, and then we have java.util.scanner, this tells you that there are a whole lot of, so the dots, let me clean this. There are a whole lot of folders that have been created in Java and that have got some of this information. So here, once you write Java, so that this tells you that there are okay. So this is the main folder, which is Java. That's where everything is. And if you install Java, it's installed in the folder Java. Then under Java, there's a util subfolder, and then under that, there are a whole lot of other classes that we can work with. In fact, if you do .star, so here, if you put star, we call this a wildcard. What you are saying is that you are importing everything that is within the util folder or subfolder. So it goes to the util subfolder. Everything that is in it, you import it. And so, but there's no point doing that, because Java has got thousands of classes. There's no point importing all those into your program and then using only just the scanner class. And so normally you have to specify what you want to. We'll be seeing some other imports as we go along. You realize that when you want to do other things, you need to import some other classes. And we'll be looking at that. We'll be seeing those as we go along. So when you create your Java application, or let me, that's not allowing me to. Yeah, when you create your Java projects in your IDE, by default, the Java imports a whole lot of other things. So you can see there's just a few of them. So these are already in your program and they are running. Of course, we are not using, there are a whole lot of things, XML, SQL, and all those things. Talking about if you want to connect to a database and so on, you will need all these ones. But you can see that we are not using any of them. All we have used so far is just this system.out.print. Of course, all these other things mean something, but for now, this is what we are using. So to be able to now take input from the user, we need to import this. Now you don't import it after you have created the class. So import, I'm going to type import java.util, and you can already see there are a whole lot of other things there that you can import, a whole lot of them, but we are just importing only the scanner class. Okay, put a semicolon. Yeah. So when you do this, now you can't do it after your class, after the public class, because what's happening is that this is also a class on its own, and you can't bring it under your class. And so here we've just imported it, and now we don't need to assign any value to the principal because we want the user to type it in. And when the user types in, we take it and then we try to run. So this is where I will now copy this. I've got this already, so control. Okay, so here, I'm going to paste this. So scanner, now that I've got the scanner class imported, now notice that if you don't import it, if I comment this and I try to use it, it will tell you there's an error there. It will tell you that you can't use this when you have not imported it, or you can't see it. So you need to bring it in. So you need to import this, and then you will see our object we've created. And now here we said principal input.net. Now you can put double here again because you've already declared the variable. So once you declare the variable, now what we're going to do is that, in fact, you could have decided not to declare it. So if I comment that, I can now put the double here. So it makes it easier to see. So you can see that I now say double principal is this, and then double interest is that. So what have we done? No, let me clean this so that it doesn't confuse us. Yeah, this and that. Okay. So we have now just asked. So when the code starts running, you create your variable integer time, double rates, assign values to them. Now you say, please enter the amount you want to borrow. So what it means that the user will now enter something. And now whatever is entered, now this is invoked. The object is able to read the keyboard and then assign whatever has been entered to principal. And then you can now use this to make your calculation. And so you can now have your interest, do the calculation, and print it out, just like we did previously. So if I run this, so it will print out, enter amount to borrow, and then it will stop there. It's not going to continue because it's waiting for input from the user. So now the system has created the object has taken the method and is ready for the user input. So when your user now types something, so at this point, if I now type this, say that this is what I want to borrow, and I enter, then it will now tell me that your loan of this, because I've told you that I'm borrowing 2345. Okay, it says if it is 2345 you are borrowing, that's the rate and that's the period, and then that's your interest you have to pay. And so each time all I need to do is that run the program, and then the user types in whatever they want to borrow. No, it doesn't matter. Once they enter, then, so control is handed to the user at the point, and then the user must interact with the system before the program can continue to run. And so once you do this, then you are able to read input from the keyboard and then go ahead to do the calculation that you want to do. And so you create an object and then use that object to take in the next method. So now if I were to put integer here, I can't leave it as next double because you can't save a double in an integer. I will need next int. And these are already described in Java anyway. So if you open your course book, you will see all these things inside. So there's next float, all the primitive numeric data types that we talked about, they all have their next. But here, the problem you might come across is, okay, it will still work because here this time, this integer anyway, but rate is double. So now if you do this, if you run, so if we run this and see, where we would see, okay, enter amount to borrow. So I enter this now. Okay, so here, okay, because it's 0.25%. Okay, yeah, so here it's still able to calculate it. So we have time times rates, and then it gives you this. Ideally, because this is integer, this one should have also been integer to avoid any conflicts. But because it's a decimal point, it should be double. If you divide it by this, okay, yeah, you get 0.25%. Okay, so here, this gives us the interactivity that we expect, or that computers are supposed to be able to handle. So you get input from a user, and then you can take that input and do whatever you want. For now, let's stick to the double so that we just have, so it's going to be next double. And look at how it is written. It's not written with a small d, because that's, like we said, Java is case sensitive. So this Java doesn't recognize this unless you use the uppercase, d. So now, so here again, we can right away see that there's a deficiency somewhere, because now if I run this, say enter amount to borrow, now I can decide to type in, the user can type in 10,000. The person is correct, isn't it? Because you asked how much to borrow, 10,000. But now what happens? Here, the system has not been configured, or the programmer has not put in anything that will handle that. And so you get an error. So the program, of course, has a deficiency. What it means is that it should be able to determine what users are likely to type in, and then you try to handle that, or you try to take care of it so that the program can continue running. I realized that when programming started, computers were mostly crashing because programmers didn't estimate what, you can't fully estimate what everybody in the world will do when they open your screen. What are they going to do? You the person developing it and look at it every day. Now you know automatically what to do. But you open it for somebody for the first time and you'll be surprised, what they are likely to do. So in that case, you, the user, you need to be able to build in things that will handle all that, because you can't be sure that anytime you run this, then the person is going to type in a number. A person can decide to type anything, or can decide to type a number that doesn't make sense, So what happens? Then at that point, your program simply crashes, and it's of no use. So what we are going to think of next is, what do we do to take care of situations like that? And so that's where the selection comes in. Selection is that we're going to ask the user, if it is this, okay, do this. If it is not this, then do that. So the computer can now be able to make judgments You know. And so depending on what the user does, is able to respond rather than just crashing, because once it crashes, that ends it. So I write this, I say enter amount to borrow. Okay, somebody comes to enter this, and then it runs very well. The loan of this is so and so. Now I run the same thing, or another person opens it, and then decides to type this, and then now the program crashes. And what else? There's nothing you can do. So you just have to turn off the computer because there's nothing back to click or anything. So what do we do here? And that's where the whole idea of selection comes in. So once we've done some input, or we try to ask the user to type in something, we now need to look at what can we do such that the system can handle all the possible things that users will do. But programming, when you develop something, there's something called usability testing. You have to get users to use your system, and then you look at how they are interacting with it, what they are accessing, and so on, how long it takes them to be able to achieve certain things. If you set up a website, for example, that you want to sell, let's say shoes, and then you ask a user to, okay, go in there and go and buy sports shoes or something. And so you, the person who has developed it, is very easy for you because you know what to click to get to the sports department or the sports section. The person who is opening it for the first time, now you can observe how the person is going about it. If they're going to take several minutes before they can be able to locate where the the sports shoes, and then go ahead to do the purchase and other things, then it tells you that your design is not good. You need to be able to do things that, irrespective of who the user is, you can always be able to achieve what you've set out to achieve within the shortest possible time. And these days, people don't have time to, it's like entering a supermarket and there's no labeling, there's nothing, everything is just put together. If you're going to look for soap to buy, you don't even know where to start. And that's why we have everything organized and labeled so that you can easily identify where to go. So it's the same thing in programming. You have to do things in such a way that people will find it easier to use the system for whatever they want to use it for. And so we need to be able to take care of whatever the user is going to do. And so the whole idea of selection comes in. What we are going to do is the simplest of all selections. Of course, you know that computers work with more complicated things. But for now, what we are saying is that we want the computer to be able to make a decision based on whether something is true or false. So if it is true, do this. If it is false, do that. And remember, we said Boolean was the data type that only recognized or that only worked with true or false. So we're going to be working with some Boolean situations. So situations where you can make that judgment or that selection, we call them control statements because they can control the execution, or conditional statements or selection statement. They all mean the same thing. So let's look at the first one, and then maybe just, yes. So the first is what we call the if statement. So it tells you if is a keyword in Java. So we just simply say if, and then we put a Boolean expression. So what does that Boolean expression mean? And this, where are we? Yeah. Okay, I wanted to, okay. When I turn on when I'm doing the show, then I have issues with, okay. So once you see if, and then there's something in parentheses here. Somebody asked whether this was a method. No, it's not. It's what's happening is that even though we said everything, no, not everything. Anytime you come across something followed by opening and closing, that's a method. It doesn't apply all the time. It's just like what we have seen with the plus sign. The plus sign is that one sign, but you can use it in different contexts. So you can add variables, or you can use it to concatenate variables and strings. So depending on where you find it, it has a different application or a different meaning. It's the same for all languages. I mean, remember Java is a programming language. And language, you can have a word that will mean one thing in one context and mean another thing in another context. And so we need to bear that in mind. So it doesn't necessarily mean that if you say table, for example, then everywhere you go is table. You understand that is the furniture or with 4 legs. Because you can go into science and you hear periodic table. Now, that table there is not the same as the furniture table. So even though it's the same word, it has different meaning in different contexts. So here you might see if and then followed by parentheses. That doesn't make it a method. What we are trying to say here is that we want to have a Boolean expression. So that expression here, and when we say Boolean, it means it's going to give us either true or false. So the if is saying that if you will do a comparison or a judgment or a calculation or whatever within these parentheses, and it turns out to be true. So if I say, for example, my age is 20, your age is 15, I can say if my age is greater than your age, then if I say that, then that is going to be true because 20 is greater than 15. So once you say if, and then you get the expression here, if it is true, then the program goes on to execute whatever statements you put in there. And so once you just see if, then it evaluates, and then let's see that I can go next. The screen just keeps freezing here. Yeah, okay. So this is just a graphic that explains what we're talking about. So you evaluate a condition. If it is true, then you run the statement. If it is false, nothing happens. But not because nothing happens because we have not told the computer what else to do. We've just said, if it is true, then do this. So let's see an example here. Let me go next. Okay, so here, I'll explain this and then we'll do the second part and then we'll end the presentation for the morning. This is a lot of slides. We can't cover all in one lecture. So now here, if we look at this program or this Java code here, what are we seeing? To start with, we can see our importation of the scanner class. So that already tells you that we are going to take input from a user. And that's why we're importing the scanner class. Now I have public class, my if statement. Again, it's just a name I've given because I want it to make meaning. So if I say if statement and so on. Now I have my main method. And now what do we have here? You can see that we've declared a series of variables. Now all these are double because I've started with double. And now we have got all this. Now, so before I go back and before I continue with this, the situation that this program is trying to handle is this. We have people who are working and they are working and they are being paid per hour. So if you come and work, we're saying that there's a rate at which we are paying you. And that rate, or I can say amount, is 5. So here it's 5.5, meaning 5 cedis 50 pesos per hour. So when you work for 10 hours, I'm going to pay you 5 cedis times 10. So we multiply by 10 and that will be your pay. Now, so we have got a variable that is called hours worked. Well, we haven't assigned a value to it because we want the user to tell us how many hours they have worked. And then we can do some calculation. Okay. And then, so if I take that hours worked and I multiply by the rate, I'll get what we call the regular pay. Now, so I've got another variable there called regular pay. Now, but the situation is this. There's something we call overtime. Overtime here is that as at closing, so people are expected to close at 5 o'clock. But as at closing, there's still some work to do. And so the supervisor or whoever it is says, okay, keep working. But because you should have closed and gone home, but you are staying here and working, I have to pay you not the same as I pay you for the regular hours, but something higher. And so for people who are working, who might have done some overtime, who understand what we're talking about here. So overtime simply means that, you know, there's time for you to close, but there's still work to do. So once you start working, it's now more or less sacrificing a whole lot to continue working. And so you are paid more. So the rate at which we pay overtime is 7.5. So 7 cedis 50 pesos per hour when you are doing overtime. And when you are doing your normal time, we pay you 5 cedis 50 pesos. So this tells you that, okay, if somebody works, and we know the regular hours is 40 hours a week, you know, 8 hours a day times 5, that's 40 hours. So you at the end of the week, you know, I ask the worker, how many hours did you work? And the worker says 40. Okay, it means that is the regular working. So I'll just multiply the 40 by the 5.5 and I pay the person. You know, that's your pay. Maybe the person says 50. I worked for 50 hours. Oh, so now it means, okay, 40 hours is your regular working hours, but you did overtime 10 hours. And so I'll multiply your regular working hours by 5.5, and that will be your normal pay. But then because you did 10 hours overtime, I have to multiply that 10 by 7.5, and that will be your overtime pay. So you can calculate your regular pay and then also your overtime pay. But that is only if you qualify for overtime or only if you've done overtime. If you've not done up to more than 40 hours, then you don't get overtime. So the whole idea now is that we are writing a program that will ask the user or the worker, enter the number of hours you worked. And when the user enters, then we're going to say if, so we'll take whatever the person has entered, and then we assign to the variable hours worked. Now remember, I was saying, we can't just use A, B, C, or X, Y, Z, and so on. If you use that, the program will still work anyway, but it will make meaning to you, the person who is reading. You know, so we're saying it's a variable hours worked. And so take now, so you can see that the scan here, rather than input, this one is user scan. So this is just to tell you that the object can have any name. It doesn't have to be one name all the time. So the other one we saw input dot next double. You know, this one we created the object called scan. So we say scan dot next double. So by the time this program runs up to here, what's happening is that hours worked would have had a value, and that value be what the user has typed in. And so when the user has typed in something, where this object uses the method to take that and assign to hours worked. So if we type 20 at this point, hours worked is going to be 20. If we type 50 at this point, hours worked is going to be 50. Now we use our if statement. So we're saying that if your hours worked is greater than, now you've seen one of the comparison operators, you know, greater than 40. So this is going to evaluate to true or false. So if this is greater than 40, now go ahead and do this. So multiply your regular pay by 40. I mean, a regular pay, which is your 40 hours, by your regular rates, and then multiply your overtime by, how do you get overtime hours? You have to take the hours worked, subtract 40 from it, and then multiply by the overtime rate to get the overtime pay. This arithmetic, if you don't follow this, then you know, so how many hours did you do? 50. Okay, if you did 50 minus 40, 10. So 10 multiplied by 7.5 is your overtime pay. Now if you did 30, okay, 30 is not greater than 40. So for that matter, we are not going to run this. So the if statement, unless this is true, this will run. If it is not, then the whole thing doesn't run at all. So let's quickly see the demonstration of this. So I'm cleaning this one, and then let me end this. Yeah, and then we come back to our ID. I think I have this already, so let me open this. Yeah, okay. Now, so here we are seeing my annotation. All right, so let me clean this. So on the slides, we saw these things all declared on one line. Now, remember the last time we were saying that if you are using, the same data type, if you are using the same data type, then you can have all of them as a line, because they are all double. So double hours worked, rate, regular pay, overtime, all of them are variables that are double. And so, but for a beginner, it's better to do it this way so that you can easily see it. So starting, we've imported our scanner class. And now we have our class. We created my if statement. Okay. Now our main method. Now we have the variables here. Hours worked, regular rates, or yeah, we'll call this regular rate now. And then regular pay. So your regular pay is just your hours worked multiplied by your regular rate. That will give you a regular pay. But you realize that if you do more than 40 hours, it will not be fair. So if you say 50, you can't just multiply the 50 by 5.5 because you'll be cheating the person. The person has done 10 hours extra. And you're supposed to pay the person more and not the same as, so I mean, somebody who has worked close at 5 o'clock and gone home, another person has stayed to work until 8 o'clock and goes home late at night, and you are paying them the same rate. It doesn't make sense. You can't pay the person who has gone home at 5, even though the person who did overtime would get more money, but of course, to motivate them to do the overtime or to also reward them for staying and working late, you give them more. And so we call that the overtime rate. So if you do overtime, you will get overtime rates. If you don't do overtime, then no overtime pay for you. So now we can see we have created our object. Now here, the next thing to do is print out something. Enter the hours you've worked. You can say for the week or type, and enter. In this case, it's just going to be, these days that we have Windows, you just type it and enter. And now once you enter, I will say the hours worked, which I've already declared here, is scan.next double. So we take that figure and then put into hours worked. Now our statement comes. So here you can see that, okay, let me take out the else. Now, so here I'm going to comment out all this, and I hope you remember when we did block comments. So I'm going to comment out all this one so that you don't get confused for now. Okay. So just take it that this doesn't exist. So for now, what is happening? We're saying that if your hours worked is greater than 40, then take first of all, calculate your regular pay. Your regular pay is just the 40 hours multiplied by your regular rate, which is 5.5. But you probably didn't even need to put 5.5. You can just put, regular rate, you can just put the 5.5 here. It doesn't matter. So, but here, now I'm going to calculate over time. So what you can see here is that it is only if this is true, that if hours work is more than 40, that you calculate overtime pay. So that's the if statement. So if I run this, so let me check. I don't have an error there. Okay, so I run this. So it says enter your hours worked, maybe for the week or whatever. So let's enter 45. Now, when you enter 45, of course, it's going to take the 45 and assign to hours worked. And 45 is greater than 40. So it is going to run. So it is going to run and say your regular pay is this and your overtime pay is that. And that's because I've done overtime. And so somebody who has done 50 hours, so you run it, and then the person types 50, 50, enter, the same thing. That person also gets their regular pay, and then their overtime pay. So Of course, the more overtime you do, the more money you get, and so on. But then, what happens if the person didn't work more than 40 hours? So if the person just did their regular working hours, no, so here I came to work, my normal close at 5 o'clock, so I worked for 40 hours. Now what happens? If I type 40 and I enter, now nothing is happening, even though I've entered. Nothing is happening because the program has not said anything after I've commented out all this. So because this is not true, then nothing happens. And so what it means that it just says, if this, then do that. So it's like saying, oh, if you are hungry. And notice that here at the end of the, even though we say all Java statements end with semicolons, this does not have a semicolon because the if is not a statement. So I can't just say if you are hungry and then I end it like that. No, that's not a statement. I have to say, if you are hungry, okay, go to the cafeteria. Yeah, so something has to be added before it becomes a statement. But here, if you are not hungry, we have not told you to do what anything else. So it means if you are hungry, go to cafeteria. But if you are not hungry, okay, then that is it. Nothing happens. So that's why when you run this, and then the thing prints out this, and I enter maybe 35, 34, enter nothing because the program has not told me what else to do. So in fact, more so if you enter something that is just like we saw, if you enter 40, if you do this, of course, you are going to run into problems because we haven't told the program what to do when it comes to these ones. So what happens? So this is where we have the else statement. So we now have if and else. And so this is the last thing that we will do for this morning. So what we're saying is that assuming that the person did not do overtime, then what happens? So this becomes false. And if this is false, you skip all this and then you come to else. So the else, now we are going to uncomment this. Now, I mean, if you come to do programming, or if you come to be doing programming, what's happening is that you are going to be seeing or see the need for commenting, because if you're having errors in your code, it's always good to comment out some lines so that you know where the error is coming from. Even though these days the IDEs help us a lot, but sometimes you need to, sometimes you can write the whole thing, everything is looking nice, but you want to run and the thing will not run, or it will tell you error. And sometimes you have to trace and so on. So anyway, so here we have, so I've now given the computer or the program options now. So I say, if you are hungry, go to cafeteria, else go to the stadium or go to the sports field, whichever. So now the person has the two options. You can't say that you have nothing to do. Because if you had said, if I had left it at only if you are hungry, the person is not hungry, so nothing else. So I'm sitting down. You are saying that if you are hungry, okay, go to cafeteria, else go to the stadium. So that's where, so now you have no option. You have to do something. So at this point, the program will run for whatever you enter, because we are now saying that else this, that is, you get your regular pay. So the hours you've worked multiplied by your regular rate is going to be your regular pay. And then we're going to say that you do not qualify for overtime pay because you have entered hours that is less than 40. So here now I run this, and then those who are qualified for overtime, okay, so me I did 46 hours in the week. So okay, it tells you that of course you have your regular pay and then you have some overtime pay. Another person comes and then opens the program, tell us how many hours you did last week. Say, oh, last week I even fell sick for one day, I didn't come, so I only worked for 25 hours. Okay, it says, well, fine, if you work for 25 hours, this is your pay, but you don't get overtime, or you don't have overtime pay because you didn't work for more than 40 hours. So now, irrespective of what you enter, you have the computer responding, unlike only the if statement. So we say the if is just a single process or selection approach, whilst the if and else is the dual or the double approach, in the sense that you can go left or right. So we're saying that okay, I've already explained all this, but let me, so we say if it's a single alternative, so you have only one way to go. If that way is not true, then nothing happens. And then the if and else is a dual alternative. And so the selection, if it is true, do something. If it is false, do another thing. And so we have if and else. So with this, the computer is now able to make the judgment that what you've entered is it, and it's just the code I've run. But I will end here. I don't want to go on to we now have things like and or and all those other things that are all part of the selection process. So you can say that if you are hungry and there is food, then eat. Because if you're hungry and there's no food, what happens? So you can do it step by step. If you are hungry, go to cafeteria. If there is food, eat. So what it means is that there are two things. The first thing, that both have to be true. So if you're hungry, okay, then you go to cafeteria. Now you can get to the cafeteria and there's no food. So you get to the cafeteria and say, okay, if there is food, now eat. You can also add else. So if you are hungry, go to cafeteria. If there is food, eat. Else, drink water. And then the other else will now come. That's the else that said go to the first if. So we'll come to a crossword called nested if and else. So we'll move on to that in the next week or next lecture. We'll do nested if and else, and then we'll do the and or. So we can have or I can say if you are hungry and there is food, okay, eat. If you are hungry or if you are thirsty. So we can be doing things like that, and all those are part of the selection process that Java has put in there that programmers can write. Of course, that's how programming works anyway, because there are always selections to do. Practically, all these applications that we are using, they look complex, but at the basic level, it is all these things that are working. I always use ATM as the example. So if your PIN is the same as what is in the database, okay, do this, else do that. And then if you enter the amount, another if the amount you're withdrawing is less than what is in your account, okay, go ahead and pay, else do this. And so we have all this if else going on. And there are also, the loops that we'll be talking about eventually. So, okay, so let me draw the curtain down here to not to overburden people too much. It's almost 10 o'clock. So anyway, does anybody have a comment or a question? I've been talking for long. So comment, question. No, this is I'm trying to always be fundamental as possible so that we can go step by step. You don't need to know programming and other things before you start learning these things. It's just a matter of deciding that I want to learn it. And once you listen to the lectures and you take the things step by step, you can cover all what we've done. I don't know that I have the book here. Let me see. Maybe it's not on this machine. Let me see. Yeah, does anyone have a comment or a question? You can just raise your hand. And then I want to see whether I have the copy. Yes, I forgot. And do I have this here? I just want to see whether I have. Oh, yeah, okay. Okay, so we have I think I have to upload. Yeah, Daniel's hand is up. Is Daniel? Yeah, you need to unmute your microphone so that we can hear you.
Good morning.
Yeah, morning.
Good morning, sir. Yeah, so please, we know you by voice, but we don't know you by face. Can you kindly let us see you?
You didn't see me the first time I came to class.
No, actually, it was,
you didn't come to class. Okay. I'll get ready, and then one of these days we'll probably meet in class, or I would. Right now, I'm at home, so I haven't even got out of my desk. So
I'm sorry, sir.
No problem. So eventually, maybe when I'm in the office, I'm using a system that doesn't have the desktop. It doesn't have a camera. So when I go to the office, even though there's a laptop, but that's not the one I'm using now. Okay, so here I was just trying to where are they? So download the book Selections, chapter 3. That is where you will see our selections. So you can see we have done some calculations here. If this, else, do that. And then we have the Boolean. All these are the operators, the relational operators and all that. So you can go through this and see step by step what we are covering here. So yeah, and then the last thing I'll talk about is the where is it? The practice quiz that I've put in there. So the practice quiz, yeah. So open the platform, and I'm sure everybody is enrolled in it. And then, so it looks like every level 200, they've enrolled everybody. So you should have access to it. If you don't, you better contact the Center for Online Learning so that you'll work that out for you. Because like I said, at the end of the day, I'm going to retrieve your data here as your mid-semester grades. So if you don't do these quizzes, then you can't blame anybody. So, okay, let me end the recording now, because I don't want to record too much.